Welcome to my talk. It's Pulsar Empowerment, Unleashing Scale and Security in e-commerce. My name is Stephen Bourke. I'm a Principal SRE of Data Platforms at Beyond. I've been here about almost 5 years working on Pulsar, and that work has been the design, implementation and operating of our platform, which I'll go into detail on this talk. I'm a member of the Data Engineering Platforms team, and that consists of myself, Ian Towie, Trevor Dowdle, and Damien Bourke. So this talk is really on behalf of the whole team. The agenda for the talk is a brief company background. The bulk of the talk will be Pulsar at Beyond, and then I'll follow up with a deep dive into customizing function auth in Pulsar. For most of its life, the company I work at was known as Overstock.com. Just last year, we acquired the intellectual property of Bed Bath & Beyond. The company was renamed to Beyond Inc. And we have several brands. The main ones are Bed Bath & Beyond, of course, and Overstock, Baby & Beyond, Zulily, and several others as well. The company is headquartered in Midvale, Utah, and we have an overseas development office in Ireland, in Sligo, and that's where I'm based myself. We initially started using Pulsar as was then Overstock in late 2018. That was for a project called Overstock Sponsored Products. That's an on-site preferred slot for partners mechanism, and it is near real-time requirements. And how it works is that all shopping site HTTP traffic gets streamed over Pulsar. And this is how the loop is closed, basically. So the slots, so essentially the ads that go out on our site get clicked, and we monitor those back in via HTTP request logs. And that's where there's a universally unique identifier in the request that gets joined up with all the data that we cached when we were rendering the page and creating the ads. Pulsar was heavily leveraged for this program, Pulsar functions especially, so most of the logic is encoded as Pulsar functions, and it was a very successful program. That really drove adoption of Pulsar at the company, which and widespread adoption basically happened from Q2 2019 onwards. It also drove the development of our in-house platform, the Unified Messaging Fabric, and this is an opinionated messaging and data platform that is built on top of Pulsar, and I'll go into that. That's mostly what this talk will be about. The platform consists of 4 clusters. So we have a prod cluster, a second prod cluster, a test cluster for development for the teams use to develop, and a GCP cluster as well. This platform is central to our event-driven data mesh architecture that we're now adopting at Overstock. Sorry, I should say Beyond. I'll probably make that mistake a few times during the talk. The key components of the platform, well, it's obviously Pulsar is the main underlying technology, and what we built on top of that is a self-service portal. I'll go into that in detail, in some detail later in the talk. But it allows for data discovery, function management, admin tasks, data lineage, queries. We have a large suite of custom connectors, so for Pulsar sync sources and syncs for connecting to Redis, Ignite, BigQuery, Bigtable, etc. Database changes, so CDC comes through on Pulsar as well. That's via Click initially, so Click is a CDC system that works with our Oracle, BigQuery databases that we use, and streams the events into Pulsar where applications can use them there. We have a function library that was developed largely by our team, but also by other dev teams at the company. Custom integrations, we offer joins, so several topics can be joined. I should have mentioned that our main data format is JSON. So almost all of the messaging that goes over Pulsar are JSON messages. It's only when there's a need for something else that's departed from. And in this join system, so it's ACA-based, it caches messages, so it'll be connected up. So joins can be connected up to several Pulsar topics, and a key, so a key at any level in the JSON hierarchy can be specified to join on. And then whenever a new message comes in on any of those topics, if there's a change in that message from the cache message, then it's joined with the cached version of the messages on the other topics, and a new output message is produced. And we have significant back-end authentication, back-end automation as well to power all this. I'll go into that as well later. So some key metrics. So we have about almost 90 projects at Overstock. So a project is essentially, that translates to a tenant in Pulsar language. It's at the company, a project is essentially a domain. So something that's not tied to a specific dev team, and often will move between dev teams. But it could be, to do with pricing or search. We have about 3,500 topics, almost 5,000 clients. These aren't unique clients, so some of these will be several pods of the same client. We have almost 1,500 functions, and so I got our average throughput over the last week, and we average at about 50,000 messages a second. Over 40,000 function calls, so Pulsar function calls every second, and about 10 terabytes of data per day going over Pulsar. Our deployment is containerized services on bare metal, so our broker, our bookie, etc. are deployed on bare metal as containers. When we add a machine to one of our clusters, it's auto-provisioned via Puppet, which is standard at our company. So that's generally a Kickstart OS install, plus Puppet is installed, a Pulse config. The actual UMF deployment is managed by Salt, which is it's another automation tool. It's in the same family as Puppet, but it's Python based, and that's what actually deploys and configures our services, so the broker, Zookeeper, etc. We are migrating to Kubernetes for Pulsar functions. Currently, we have disaster recovery capabilities via GKE, so Google Kubernetes Engine in Google Cloud. That works by so every night we back up the state of our clusters, and by the state there I mean essentially a full list of like all the tenants, the namespaces, topics, all their associated permissions and configs, functions, all the function states. Everything is backed up to a cloud storage bucket nightly, and then we have tools that use that data to deploy a cluster and fully configure it in GKE, and we test that out regularly. It used to be weekly; we're in a monthly cadence now. We evaluated full Kubernetes Pulsar deployment, but with our on-prem hardware, we found that not to be advantageous. Our current containerized services is optimum for us. So I mentioned opinionated framework, and what I mean there is that it's not just that say a dev team will just use Pulsar in whatever way they want. We have a framework, and they can create topics through that framework, and that enforces our data model. And this is just a very high-level overview of the data model. So ingest, so data coming into Pulsar is via data source topics, and each data source topic there should be a one-to-one correlation there with a source of data, naturally enough. So whether that's an app or a Pulsar source, so connecting out to for example Kafka or to some other source of data, that should be come onto a unique topic. And then if they need to be joined with other topics, if they're compatible schemas, that can be done, of course. And at that point, processing happens. So as Pulsar functions, this would typically be transforming, filtering, enriching, etc. So enriching would be hitting a cache to add additional properties to a message. And at that point, so the resulting data on topics can be exposed as a feed. And feed topics are consumable throughout the company. Just a bit of water. So, and I'll go into later, but feed topics can be discovered through our portal and consumed by teams. And some of these diagrams just show these scenarios I talked about. The bottom one would be with no apps involved, the data coming in from, for example, CDC events from a database and being synced on the output to some other persistent or other system. So going into a bit more detail on the portal. I'll go over the self-service aspect on the next slide, actually. But we integrate with our LDAP system, so our in-house LDAP, Active Directory-based system. We use ServiceNow for security approvals. We integrate with our microservice platform, which is Kubernetes-based. The self-service, when a team wants to set up a new project that will result in a new Pulsar tenant being created, they do this through ServiceNow, so it gets security can easily approve it, and that kicks off a chain of automation, which I'll come to pretty soon. But after that point, all requests are done through the portal, so they can create data source topics, deploy functions, search for existing feeds and subscribe to them. That again triggers automation. So if one of those topics did have high business impact data, so such as personally identifiable data, credit card information, financials, etc., then that request goes again through the automation. It goes to ServiceNow for the security team to approve. When they approve it, it goes back into our automation and results in a function being deployed in Kubernetes, in Pulsar, which copies that feed into the projects, into their own tenant, into this project's own tenant, where they consume it. The reason we did that there was just for isolation, so that teams can't incur backlogs and storage in another team's namespaces. Also admin operations like clearing backlogs, unsubscribing, changing function parallelism. They're all done via the portal as well, just by point and click, or they can be done by automation either. Functions are managed, so the images the top image kind of shows a graph representing functions and topics being tied together, and this is part of our data lineage system. And in here, this is all the components in this graph. So yellow are Pulsar topics. You probably can't see much of it, but there's also purple bubbles are functions, and sources and sinks are blue. And you can right-click on any of them components and, for example, change a function parallelism, clear a backlog, stuff like that. On the bottom right, that's the data discovery. So you can search for feeds. So when a feed is deployed, it'll be given, obviously a name and also a description, and that's what powers the search. And then you can request to consume from that feed, which if it's not high business impact, so personal information, sensitive information, etc., that happens right away. So it triggers that copy into the destination project. Otherwise, it goes by security. And the back-end automation that powers this is Python-based. It's all implemented as Pulsar functions, so where we are eating our own dog food, of course. The logic is encoded as directed acyclic graphs. You're not expected to see this graph down here, by the way. This is not a directed acyclic graph or a DAG. This is not one of them. This is how our automation is set up. It's just a snippet of it, obviously, but it shows it's the same color scheme as before. So topics are yellow, functions are kind of purple color, and green is for external apps. So, like for example, when we head out to ServiceNow. A directed acyclic graph is essentially something that would look a bit like this, but there wouldn't be any cycles. So here there's some cycles. You may not be able to see it, but like you can create loops through this graph, and this is cyclic. If we got rid of any kind of upward pointing arrows in this graph, then it will be a DAG, a directed graph. And DAGs are great for decomposing tasks and parallelizing them. I'll go into how we use DAGs on the next slide, but basically it's for implementing high-level operations. So as an example of one of our automations, one thing that we support, that we provide is it's basically a little bit of extra logic that sits on top of a standard Pulsar dead letter topic. And this followed on from, we migrated from WebLogic to Pulsar in-house, so at the company. And a feature that some teams requested was, in WebLogic they had dead letter queues, messages, if they didn't get processed, they'd build up on the queue, and they could just see what the problem was. Maybe if the app needs to be fixed, they could redeploy their app, and then release the queue back into their app. And that was a feature that was requested. So we implemented that in Pulsar. So this diagram on the bottom left kind of shows that. If you can't see it, the main, you could pretty much ignore most of the top line, except to know that this is the top yellow is the topic. the kind of turquoise thing over here is an app consuming, and this is the dead letter queue at the bottom. So when an item goes onto a message goes onto the dead letter queue, there's a Pulsar function subscribed to that dead letter queue, that dead letter topic, and this is just a pass-through function, as we call it. So it's basically just a one-liner, a function that just takes its input and returns it again on the output topic. And the default state of that function will be to be stopped. So that means that messages will backlog on the topic going into the function, and teams then can once they so if it was, for example, if the data was not suitable to be processed by the app, they could clear the backlog or redeploy the app and release the messages, and they go through this replay topic. This is just a kind of an intermediate topic that only this app will be subscribed to, and it will be under the same subscription as the main input topic. So messages will come back in and feed the app, and that's actually implemented. This is so as primarily the logic that are specific to this are contained in a single function, and that's to render this DLQ. And what happens is, so a simple JSON message comes in, just specifying a role, a topic, and a consumer name, the project that it's part of. And this function, so this is a Pulsar function written in Python, and it just breaks that down using our library into the components that are necessary. So that would obviously mean that it would result in a function getting deployed, permissions being granted on several topics. That function will be stopped. Request functions usually are deployed in a running state. It will be stopped, whatever permissions need to be granted are granted. And where a DAG comes into this is, I should say that it can just specify minimal operations. So if it grants permissions on a topic, then the library code that gets pulled in will ensure that the tenant exists, the namespace exists, the topic exists, and then grant permissions. And a DAG is created from all those operations. They would be essentially Pulsar REST operations, so the Pulsar admin API commands. They get assembled with their dependencies. So in this case, for example, if a namespace is being created, then obviously the tenant must exist first. So a DAG is built up of those operations, and then it's sent into this next function, and that peels off the leaf nodes in the DAG. So it will do any components without dependencies. It will do those and send it back out. This next function actually executes those commands, so it hits the Pulsar REST endpoints to action those requests. And then that feeds back in a loop, so it strips off the leaf nodes, and the remainder of the DAG goes back through again until it's fully processed. For our observability, fairly standard. We use Grafana, Opsgenie for alerting. We have a Microsoft Teams integration for alerting teams of like non-critical operations, informational stuff. We use OpenTelemetry for tracing and also for function logs. It's fairly standard stuff. So on to customizing function authentication. First a little bit of background about why this is necessary and why it was necessary to customize it for us at Beyond. So a function is essentially just an application running. So if it's in the Kubernetes runtime as a Kubernetes pod, and this pod, so the application running, so the function that's running in the pod needs to authenticate with the brokers, and so the function worker needs to enable this authentication somehow, and how this is done is with the FunctionAuthProvider, and so this is extensible in Pulsar. It provides the cache, update, and cleanup auth data methods, which can be overridden. So the Kubernetes FunctionAuthProvider implements the standard FunctionAuthProvider, but adds the configure auth data stateful set method. And so to give a specific example, we'll step over the Kubernetes secret token auth provider, which is using JWTs to authenticate. And so the flow really here is that so when a request comes in, so HTTP request to the function worker to do some operation on a function, to create or update a function, the token. So if it was a JWT, so that would come in as for example as a authentication bearer token in the HTTP header. That gets captured and written as a Kubernetes secret. Then the stateful set is created that creates a volume from this secret and mounts that volume into any pods that will be run. So basically there'll be a pod which contains the function, and in there the secret is mounted as a file that's made available to the Pulsar function inside the pod. And then the auth config is just passed into the function as well, as with and in this case it will be standard. It will be the client auth plugin would be token, and the token auth, the client auth parameters would be just the path, which is the mounted Kubernetes secret. And this is just the same thing as a flow diagram. So at Beyond, we use LDAP, as I mentioned earlier, for our authentication. So we need to integrate with that system. And how we do this is that, so every function is given a role, which is just its fully qualified function name. And when the function worker is updating that function, so this will usually be coming in via the portal. So the portal has a token that it uses, which is essentially a super user token. And at that point, our custom provider discards that token and creates a token based on the function name. So it just uses the fully qualified function name as the role and creates a token. So this provider has access to the signing key, of course, so that is itself a Kubernetes secret that's only that's limited to the function worker process, to the function worker stateful set, I should say. And so the function worker can generate this token, and from there on it's pretty similar to what happened before. It mounts that token it creates a volume from that token and mounts it into the stateful set pods. And from that point on, it's the same. So it's a standard JWT that the function can use and present back to the brokers. That's basically the end of my talk. So thanks for attending, and hopefully I'm there live to answer any questions. So thank you.